This is BubbleFoot, a working proof-of-concept stage prototype on its way to become a fully functional commercial product. The purpose of BubbleFoot is to enable carboxytherapy. It is bathing the patient's feet in water enriched with microbubbles of carbon dioxide. Such baths are an auxiliary therapy in the treatment of diabetic foot syndrome. The first assembled version is equipped with a DC electric pump, 2 electric heaters, pressure gauges, a thermometer, necessary pipes and valves, a carbon dioxide cartridge, and a triple-pipe microporous membrane. It is designed to be a standalone, stationary product. Optionally, the whole setup may be placed on a movable platform for easy transportation. Let's see how our prototype works. First, we need to fill the bathing tank with water. While the water level gradually rises, we can turn the pump on in recirculation mode and start the heating process. When the temperature reaches 37 degrees Celsius, which is the temperature optimal for the treatment, the bathing tank is ready and we can switch from recirculation mode into operating mode. Now we can see a stream of water coming out of the outlet. It carries tiny bubbles of carbon dioxide, visible as a fog-like structure. It is much more visible in the laser beam, and its density depends on the size and concentration of generated microbubbles. This is the desired effect, enriching water with gas bubbles capable of penetrating the tissues being treated through the pores in the skin. After a couple of minutes, the exact time is still to be determined, the concentration of microbubbles reaches the desired level and the treatment may begin. The patient may place their feet in the tank and relax. The duration of a single bath is about 15 to 20 minutes. Bubble generation is active during all this time. When the bathing session is over, the patient removes their feet from the tank and the disinfection phase begins. After a few minutes of disinfection by ozone microbubbles, water may be discharged from the tank and the whole procedure is concluded. What will come next? During the design and prototyping phase, we found several opportunities to improve the microbubble generation process. For testing purposes, we decided to use manually operated valves. In the final product, they will be replaced by electric equivalents as part of the automation. Automation is a very important feature, especially regarding the experience of end users. The brain of BubbleFoot will be an ATMega-based microcontroller that will gather information from sensors, thermometer, flow meter, pressure sensors and water level indicator, and control the valves, the pump and the heaters, and will communicate with the user via an LCD display, push buttons and a sound beeper.